Welcome to our new unit on atmospheric pollution. Now that we've talked about certain air pollutants, let's talk about the main difference between two categories, primary and secondary. Trying to understand pollution is an attempt to reduce pollution. It's important to understand if a particular pollutant is coming directly from a source like a smokestack or emission, or if it's undergone some sort of transformation, if that makes sense. So we categorize them in two ways, primary and secondary. So primary pollutants are polluting compounds that come directly from a smokestack or like an exhaust pipe or some sort of natural emission source. They are things like carbon monoxide, carbon dioxide, SO2, NOx. Even many VOCs are also considered primary pollutants, like gasoline that you burn in your car, or things that make like a liquid vapor. Secondary pollutants are primary pollutants that have undergone some transformation in the presence of like sunlight, water, oxygen, and other compounds. It's basically interfered with a chemical process. So because solar radiation provides energy for most things on Earth, and because water is usually involved somehow, secondary pollutants usually become more rapidly available, and they go rapidly into the air when it's during the day and it's in a wet environment. So perhaps the best example of this is ozone. It's an example of a secondary pollutant. Ozone is formed in the atmosphere as a result of the emission of a primary air pollutant, NOx or VOx, in the presence of sunlight. So the main components of acid deposition sulfate, that's NO4, that's SO4 with a -2 charge, and nitrate, which is NO3, -1 charge, are also secondary pollutants. But because of these secondary pollutants, we're going to discuss that more later, but trying to control secondary pollutants is necessary when you try to consider primary pollutants are creating them. So there are lots of factors that may lead to the breakdown or the reduction of these secondary pollutants. Do you remember when we had that discussion about Chattanooga? They tried to reduce their ozone concentration in the air, and then in order to do that, they focused on the compounds that led to the ozone formation, NOx and VOx, rather than just focusing on ozone itself, I guess is the point I'm trying to make here. So to visualize this, the transformation from primary to secondary pollutants requires a number of different factors, mostly sunlight, water, and you can get water from the atmosphere or in clouds. It doesn't have to necessarily be rain, but you can see that most suspended particles that come from volcanoes, car emissions, factories, in general, household things, they go into the atmosphere as suspended particles that are primary pollutants. And then they interact usually with water and sunlight, go through some sort of chemical transformation, and they become secondary pollutants like ozone, or they come apart to form these anions. And so, this is a process, and this is important when understanding how we make like legislation, or who do we blame for certain things. Environmental scientists are concerned citizens. They direct their attention towards air pollution that comes from human activity, because human activity is something that we can affect and control, I guess. And it's basically the source of air pollution and the process involved in creating air pollution. Natural emissions are also a consideration. Those are things like volcanoes and lightning and forest fires and plants. They're both living and dead, and they all release compounds that are classified as a pollutant, technically. Volcanoes release sulfur dioxide, particulate matters, carbon monoxide, and nitrogen oxides. And lightning strikes create nitrogen oxides from atmospheric nitrogen. Forest fires release particulate matter like nitrogen oxides and carbon oxides. And living plants release a variety of VOCs, including ethylene gases and terpenes and all kinds of other harmful pollutants into the air. And the fragrant smelling of certain things, like even conifer trees, like a pine tree or a fir tree, and the smell of citrus fruits, they can also, that we like to enjoy their fragrance, or we like to plant more of them because we like the fragrance that they put out. These are all precursors to photochemical smog, believe it or not. And long before humans created pollution, VOCs were really common, and plants gave rise to smog and photochemical oxidation pollution. One thing that comes to mind is like forested mountain ranges in the southern United States, like the Blue Ridge Mountain area or the Smoky Mountains. All right, so if you concentrate on that area, large non industrial areas where there's lots of fields and lots of agriculture that takes place, um, these places have had a large soil depletion. And that might be the story that we talked about earlier about the 1930s Dust Bowl. All right, so climate change estimates that across the globe, sulfur dioxide emissions are 30% natural, and 44% of the oxidized or nitrogen oxide emissions are 44% natural. And these VOC compounds are 89% natural. Okay, so it is a natural process. However, in certain locations like North America, humans have contributed to this much greater percentage. We've even made everything up to 95% nitrogen oxides and sulfur dioxides. So regardless of how you look at it, we have definitely increased emissions to the already natural process that's taking place on Earth. I mean, just think of Mount St. Helen. Mount St. Helen in the 1980s, when it erupted, it put all this stuff into the air, and then prevailing winds carried all of this emission stuff in Washington State and distributed it all over the United States. So when rainfall occurred, we had all of this acid rain that just caused a major natural acid rain process in the United States. So we already have this natural process going on, and humans are adding more to it, which is the one thing we can control. Anthropogenic emissions, in contrast to these natural emissions, these are emissions from human activity. And these things are monitored, regulated, and in most cases, they're controlled. The EPA reports periodically on this emission source in the air pollution criteria, and it also is a listing of pollution sources, and it also publishes everything, even from pollution from road vehicles to power plants to industrial process to waste disposal. So everything's reported. The Clean Air Act and its various amendments require the EPA to establish some sort of control over this anthropogenic emissions. Pollution is harmful to human health and well-being. So the term human health means that the health of a human population, and that includes elderly, children, and even sensitive populations, people who have asthma. So the term welfare refers to the visibility, the status of crops, natural vegetation, animals, ecosystems, and buildings. Throughout the National Ambient Air Quality Standards, what we call AAQS, the EPA periodically specifies concentration limits in certain areas. So for each type of pollutant, the NAAQS notes a concentration that should not be exceeded over a specific period of time. And as we discussed earlier in Chattanooga at the beginning of this, it particularly described a standard for ozone. So for each U.S. average of ozone concentration, it's developed in an 8-hour period. So right now, we should not exceed 0.075 parts per million in an 8-hour period. That is 0.075 parts of ozone per million parts of air volume, and that needs to not exceed 4 days. So an average over a 3-year period violates this specific law for air quality. So I know that sounds slightly complicated, but that's how these laws are written. They're written in a standard, and so that's how we sue or ticket governments or buildings or factories, is if they have to violate a certain standard that's been set by law. So when humans create pollution, that's an emission source or criteria of air pollution in the United States. You can see here from this diagram that this is in millions of metric tons. So off-road vehicles or non-equipment vehicles, we get to 45 million metric tons, and that would be like in the production of anything. Um, we'll just say just in general in metric tons. And then also it starts to be separated by carbon monoxide and nitrogen oxides and sulfur oxides down further. There is a limit. It's not that they can't produce these pollutants, but they all have a specific amount that they can put into the actual atmosphere. So in general, the EPA data shows that the on-road vehicles that are in the transportation category, those are the largest source of pollutants. Nitrogen oxides are produced largely from electricity generating plants, and then sulfur dioxide, and I mean power plants. Sulfur dioxides are produced largely by dust, and that's an industrial process, but that also comes from electricity generated plants and fires, waste disposal, that type of thing. So in general, we can say that the human emission process for the four major categories have really two sources. Carbon monoxide has a source of on-road vehicles and non-road equipment. Nitrogen oxides, it's on-road vehicles and non-road equipment as well. Sulfur dioxides, we're looking at the generation of electricity and also fossil fuel combustions. And then particulate matter is really by road dust and this miscellaneous category of different things that produce this particulate matter. Each year, the EPA issues a report that shows the national levels of the 6 major air pollutants. And this figure shows that all the pollution has really decreased in the U.S. over the last two decades. It's really only ozone and some particulate matter concentrations that are now exceeding on a regular basis. The case where particulate matter exceeds the national standards are really not evident in this figure, but lead has had a decrease, the most significant, because it's really no longer added to gasoline. And this is good news for the United States. There's a less positive version of this in other parts of the world. Largely Germany and Poland and even the Czech Republic, they can still contain a great deal of brown stuff in the air, coal, and even this other fuel sources, because there's still a lot of stuff like in their coal and their emissions and their oil burning process. It's not up to our standards essentially. So emissions from like combustion have this high sulfur content, and they've really caused what we call the black triangle, and it's become one of the most polluted areas of the world. So not only in addition to human health problems like respiratory illnesses, but also it causes an issue in the forest ecosystem in this region, and it's damaged everything over the last 25 years. In many parts of Asia, air quality has been so severely impaired by particulate matters and really sulfates that the visibility has been reduced by 20%, and people just really can't even see down the street. So a variety of non-governmental and environmental organizations have prepared a list to indicate the top 10 or top 20 most polluted cities in the world. And these cities are in China and India, and usually the whole German, Poland, Czech Republic area. But usually China and India are at the very top of that list.